All right, so for this video, what we're gonna do is take multiple LEDs and then we're gonna shift the on state from one LED to the other. And this is just going into our bigger project when we're trying to um, essentially make a strobe light where it would start from, let's say, the first LED, which is the least significant one, and then it'll go all the way to the left to the most significant one, which is at pin 8, and then all the way back again. So this is just going to be a little video explaining how to actually get it to shift the logic. In the future, then we're going to actually involve loops where it will do it automatically. But at least starting from the beginning, we're going to open up THRSim. And as you see, we have the registry. We don't need that. Or the commands. We want to open up our old circuit where we had the LED initially with our code. This is what I had. I had test. And if you want to figure out how this code operates, I explained into detail in the previous video, but we're just going to be adding to it in order to, let's see, have the new updated functionality. So in order to do it, and I'm going to do a little bit of testing out, I want to see if you have to initialize each LED by having the EQU and setting it to individual registries, or if you don't need to actually do that, if it does it automatically through the LSL function. And actually, as a quick review on what the LSL function is, which is what we will be doing, um, essentially LSL stands for logical or logic shift left. Essentially, this is how we're going to be shifting the logic from the one LED pin to the next one. So let's say if we had like a binary, let's say it'll be 0001. What it would do, applying the LSL to to 0001 would shift it to the left one. So I'm not sure if it's going to be doing would change to 0010 or no, yeah, shifting it to the left would do 0010. Or if you wanted to do it as third time, then it'll be 0011. Or would it be 0100? I'm pretty sure it's 0011 for the next one because it would be from 1 to 2 to 3. That's what I'm pretty sure it does. But either way, first what we need to do is we need to initialize our LEDs. And even though you can connect it from here, I've had problems where some weird stuff would happen or it would disconnect randomly. So it's just good to first place the pin or place the LED first. And after that, then you would first set, if you wanted to reorder it, you would click this tile button and it would just make it all kind of evenly spaced for you. It's just better to look at. But then you can right click and press connect. And then you can set pin 1 or LED 1 to pin 0 and connect. And then LED 2 to pin 1. And then LED 3 to pin 2. Just like that. Now, if you want to see where the LSL function is, it's mentioned in the project that we're working on, Project 1. As you can see right here, it's saying that we're going to be using LSLX. I don't know why it's LSLX. I was just using LSL and it seems to be working fine that way. But it moves the on LED to the next bit on the left. So essentially, I think using LSL would mean it would swap to 1, 0. Well, no, it would be 1, 1, 0, 1, 1. So that it would be 1, 2, and 3. That's what I'm pretty sure. But essentially, if we wanted to shift it to the left, because as you can see, if we first initialize it, let's say we start from where it is right now, as you can see, only one of the LEDs are turned on. So we want the next one to turn on. So in order to do that, we would do, let's try this. LSL, logical shift left, and we want it to be the LED one that shifts to the left. So as you can see, it's first on LED 1, and then when you press run, as you can see, it shifted over to LED 2. And if we did it again, pressed on, okay, so it's still on LED 2. So what I think, in order to do it again, you can just do LSL LED 1, because then it would shift wherever the LED is right now and shift it over again. So it should go to 3. As you can see, it does that. So if we reset the circuit, now what it's going to do is going to set LED 1, which is equal to the register at 1004. It's going to start the count at C000. What we're going to do is load the decimal number 1 to LED 1, which is the register up here. And then it's going to store, no, that's already said. STAA is storing it to the register, which is LED 1. Then it's going to shift the 1 over to the left once, bringing it from LED 1 to LED 2. And it's going to shift it again from LED 2 to LED 3. So this is starting from 0. So we should see the light start at LED 3 because it shifts once and then shifts twice. So as you can see, when we start it, it starts on LED 3. Now, with that being true, what I can do now is take what is currently and I can shift it to the right by doing LSR LED 1. So now it's going to take the information that's LED 1, which is now LED 3, or the third LED, and shift it to the right once. Okay, so it seems like, no. It's not, it seems like it doesn't work for LSR. So I need to figure out how to actually get it to shift to the right. But at least for the time being, we know how to shift the LED to the left. So if we reset and we just run it as is, we see the LED starts at 1. And if we do the LSL function, LSL LED 1, it will shift to the right or to the left. As you see, it does that. Okay, so in order to have this automated, in the next video, I'm going to learn how to use loop functions in order to have it slowly swap to the left. And that's going to be the major breakthrough in our project, having it automatically shift from the rightmost one to the leftmost one. And then another layer to that will be to have a delay in there so that you can see each LED turn on individually. That's going to be the crux of our project. But then after that, we will have it so that it goes to the right first, and then it goes to the left first. And we can change the time that it does, and that's going to be the layers. But this is good progress so far. I also need to figure out how to shift it to the right. And when I know that, then I'll make a video on it. But that's pretty much it for this one.